In this video, we're going to again look at energy transfer, but we're only going to focus on thermal or heat transfer. So if we have two objects at different temperatures and we put them in contact, heat flows from hot to cold or high to low temperature. Again, energy is conserved, so the amount of heat from our system is equal to the heat of our surroundings, but opposite sign, because here our system's gaining heat and our surroundings losing heat. So if we have metal and water, different temperatures, the heat lost by the metal equals the negative heat gained by the water. Just same numbers, opposite signs. And to calculate thermal energy change for substances, we need to know three things. We need to know, two things for each substance. We need to know their mass and their specific heat capacity, and then overall we need to know the change in temperature. So let's look at our equations here. Heat of the metal equals minus heat of the water. The heat of the metal is based on the mass of the metal, our specific heat capacity of the metal. And specific heat capacity is how much energy does it take to change the temperature of a certain weight of our substance. We'll see this in the next slide. Multiplied by our change in temperature of the metal. That's equal to the minus mass of the water, heat capacity of the water, and the change in temperature of our water. Alright, so let's take a look at how we use these. I have two substances, A and B. They are at different temperatures and they come into contact and reach thermal equilibrium, which means they are at the same temperature. The mass of substance A is 6.15 grams, and initially the temperature is 20.5 degrees centigrade. Mass of substance B is 25.2 grams, and initial temperature 52.7 degrees centigrade. At thermal equilibrium, the temperature is 46.7 degrees centigrade. Now, if our specific heat capacity of a substance B is 1.17 joules per gram centigrade, what is the specific heat capacity of A? So here's our units of specific heat capacity. Change in joules per gram degrees centigrade. So how many joules does it take to increase 1 gram of substance by 1 degree centigrade? It's basically what it's saying. But see if you can solve this. Seems like a complicated problem, but it's really not once you know the equations. So go back to the previous slide, look at the equations, and come back if you have an answer. Alright, let's take a look. So Q metal equals minus Q water. Q metal is mass metal, CS metal, T metal, delta T metal. Q water minus mass water, CS water, delta T water. And mass of the metal, 6.15 times our C, don't know. Initially it was at 46.7 minus 20.5, and our water is minus, well, not our water, but our other substance is minus 25.2 times 1.17, that's our C, multiplied by final temperature minus initial temperature. And now we just have to do some math. So we get 161.13 C. Remember, C is our specific heat of substance A, equals 176.904. We solve for C, and it's 1.10 joules per gram centigrade. So the hardest part of this problem is just declaring your variables. Once you declare your variables, it's just algebra. Alright. That's it for this one. See you in the next video.